Welcome to day 2 of chapter 2 as we explore more in the land of statistics. Today we'll be discussing and calculating out measuring centers, different measures of center, and spread as well. So first things first, let's find the mean, median, and mode. We're going to do it of this first data set right here. So this data set right here, we're going to find the mean, median, and mode. So the mean is add them all up, divide by 11 because there are 11 data points. We've done this already once. If you remember from class, our mean, in this case it will be mu, because it's a whole population of values, is equal to 9. The average was 9. The median is if I take all these data points and list them from lowest to highest, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and find the middle number, I'm going to find that my median, which we'll call just capital M, our median is also 9. And then the mode is the most often occurring, and since in this case every data point happens only once, there are no repeat values, we say that this one has no mode. If we were looking at this data set, obviously 8 is the most common occurring value. So 8 would be the mode. The mean on this one, we did that calculation also, is also 9. And in this case, the median, if I list them lowest to highest, there's a whole bunch of 8s and then a 19. The middle number, the 50th percentile number, is an 8. So in this case, the median would be an 8. But now we're going to go on to standard deviation. Standard deviation is a measure in statistics that tells me the average distance of every data point from the mean. Once again, it is the average distance of every data point from the mean. And here's how we would calculate it. We start by taking a look at this. We're going to look at every data point, and we're going to look at the average. And we're going to take every data point and subtract the average. Remember, the average we said was 9. The mean was 9. So if I take every data point, so x is a data point, so 10 minus 9 gives me 1 right here. 8, the next one down, 8 minus 9 is negative 1. 13 minus 9, that gives me 4. 9 minus 9 is 0. And then fill in the rest of those. Negative 2 and negative 4. And if I take each of those and square them, that's what this next one is. So I take x minus mu. So here I'm going to take x minus mu, this value, and square it. So again, 1 squared is 1, negative 1 squared is 1, 16, 0, 2, 25, 9, 25, 9, 4, 16. And then the sum of all of those is 110. What we just did, this number right here, is capital sigma x minus mu over, squared. So this means if I take every x value, subtract the mean from it, and square it, which is this column, capital sigma means then add them all up, the sum of all of those values, sum them all up, that's this. And if I have a population, I'm finding lowercase sigma. Lowercase sigma is the standard deviation of a population, which this is. So I would have 110 over capital N is how many data points were there? There are 11 data points. So my standard deviation becomes 3.16. Oh, and then, sorry, I'm missing something very important. It somehow didn't get brought over when I imported the slide. Then you take the square root of the whole thing. And that would be 3.1622, a lot more decimals after that. If I had this as a sample, not as a whole population, instead of using the population mean, I'd use the sample mean. So population mean is mu, sample mean is x bar. It'd still be the same thing. If this were a sample, I'd add them all up, divide by 11, get 9. This would be the same process. This would be the same process. I'd still get this number. That would be this top value here, but the difference would be, and this would be the square root of, I would have 110 over, and then instead of 11, it would be 11 minus 1, which is 10. And we'll talk about that later when we talk about something that's called degrees of freedom. And if that were the case, then my standard deviation S would be 3.16 3.3166. All right. And then this one here was sigma. Biggest thing to remember, sigma means if it's a whole population of values, which you'll have to know, we use sigma. If it's a sample, then we use S. And the standard deviation is the measurement that says this is the average distance of any data point from the mean. So if I were to pick a data point at random, I would say, well, how far away from the mean am I? On average, I would be this far away from the mean. If I picked one of these points at random, I would anticipate being this far away on average. That's the standard deviation. So if you have a graphing calculator, here's your process of doing it. If you have it out and look at this, hit pause and grab it, but you hit the stat key, and then the first item is edit, and then it says enter, and then you'd see this list of numbers, L1, L2, L3. I'll show it on the next slide. And that's where you'd put your data. If you do second quit, it would take you back out to your home screen. And then you do stat, you'd arrow to the right to calculate down to the first thing that says 1var stats. And I'd do second one, I'd hit the second button, which on my calculator is blue, and that would give me list one. It looks like these here. Stat, edit, right there it is. I'd hit enter, it gives me this list, and that's where I enter the numbers. Then I go second quit, and then go stat, then I'd arrow to the right to calculate, and then down to 1var stats. It would give me this. In order to get L1, I'd hit second key and then the number 1, because if you look, it's the L1 is in blue. And then go down to hit calculate, hit enter. It gives you this numbers. Here's the average. There's the standard deviation if it's a sample. Here's the standard deviation if it's a population, which we just did. And if you keep arrowing down, it'll tell you the minimum, the first quartile, the median, the third quartile, and the max. Lots of information there. So now, either using a graphing calculator, the Stats Blue website, and histogram function, because if you use the histogram function, you can find these values. I want you to take a look at data set 4 and the X values, and I want you to find the mean and the standard deviation for that data set as well. Doing this primarily just to practice how to find these values. You'll need to enter these data, since you can't just copy paste, but you have to enter those 11 data points by hand. We will be in the habit of doing this a lot, very often. So again, spending a little bit of time right now and just getting more and more comfortable with either this program, Stats Blue, or a graphing calculator if you have one, will make your time more enjoyable later on when we're doing lots of data sets. So again, just take this list, either manually enter it into Stat Blue in the histogram function, and it will spit out to you the mean, the standard deviation, the median, all that kind of stuff. But we are not going to be doing it by hand. The purpose of doing it by hand on the previous slide was just so you got a sense for where is this number coming from and why do we call it the average distance of data points from the mean? Well, we call it that because if we take every data point, x sub 1 or x sub n, they actually have in some equations, minus mu, so each x value and square it, the difference is going to be positive or negative, but then you square it and divide by n minus 1. We'll say not that, because I used mu, so it has to be capital N for a population. Take the square root of that whole thing. All right, so the squaring, and then the average, and then the square rooting. So we get the average distance. So they're not inverse operations, but it's similar to that. But that's how we get the idea of the average distance of every data point. So the data point, how far it is from the mean, square it, divide by how many data points there are. That kind of tells me on average how far every individual data point is from the mean. Then we're going to have scenarios here where we have a histogram. Here we have a histogram. You actually have the data points. This is all the cell phone contacts, male and female. And if I have this type of a histogram, it's possible if I have a histogram, but assuming in this case, I have a histogram, but I don't have the data set, I can take a histogram and estimate the mean as well. So the mean, here's how I would go about doing that. So first I'm looking, okay, so this is 200 here, so that means that point there is 100. 100 here, and that means this right here is 50. So that means the midpoint of this, halfway between 0 and 50, is 25. And it looks like I have, so this is up to 5, that's 10. So 5, 6, is that going to be 7, and then 8, 9? Or is it more up? So I'm going to guess that this is a little bit more. So it's probably 8. What I then do is say, well, since I don't have all the data points, I know that this interval from 0 to 50, which the center of it is at 25, has 8 data points. So I'm going to take 25, which is the variable value at the bottom down here for number of cell phone contacts, and there's 8 of them. So 25 times 8. And then I'm going to add to that the next interval. So this next interval going up, so this one here, goes from 50 to 100. Well, the halfway mark in 50 to 100 is 75. And it appears that that one occurs 10 times. So I'm going to have 75 times 10. Plus, I'm getting the idea here, seeing the trend of what's going on. This halfway up between 1 and 150 is 125. And it looks as though that bar is in between 15 and 20. If I use this same thing, calling that 8, then that's probably 18. So I'm going to have 125 times 18. And I keep going on there. And I can estimate the mean of that data set, and it's probably going to be close to the actual mean. Now, in this case, we have this raw data, and we could actually find the mean. If we don't, this is how we'd use a histogram to find the mean. There are, in this case, I believe we said, or just for convenience here, let's say there are 71 data points in this population of values that I have. If there are a total of 71 data points, that means this is a nice odd number, so the median, the 50th percentile, if I listed them lowest to highest, the middle value here, all these, there will be 35 data points down here, 35 data points up here, and this one data point is the median. I can find, or actually I can estimate the median if I have a histogram in the same way. So 35 data points. Well, here I have 8. Here I have 10, so I have a grand total of 18. Here I have another 18. So 18 and 18 is 36. 35, that's the 36th data point. So my estimated median would be in this interval. And I have no idea where the data is in that interval. So again, I would just use the midpoint. So again, all I did is said, okay, 71, half of 71 is 35 and a half. So 35 below, 35 above the middle one number, because right, 35 and 35 is 70, and 1 is 71. So that middle number is the median. So there are 8 data points here, 10 more here for a total of 18. Another 18 is 36. So that is the 36th data point, 35 and 1. I can't say it's closer to this edge or not because, again, I don't know, assuming I'd have just a histogram. So my estimated median will be 125, which is the midpoint of that interval. And then the mode. Mode is the most often occurring, which is easy in this case. It's the highest bar, which in this case is also the 125. So here my mode is 125. So that's how you can use and find the mean, median, and mode from a histogram if I do not have the raw data set. Totally new topic as we move on. So switching gears here, and now what we're going to do is some random numbering. But before you do that, you need to go into your data set that we had from class and click on that arrow and I'm going to add a column, depending on which column you choose. I'm choosing to add a column before it. So in between the timestamp and the number of cell phone contacts. And then I'm going to number them 1 through all the way down to the bottom and the last person. So now this number 1 will always be related to, and this 14 related to whatever data they have there. And the reason why we're going to do this is now that we've numbered them all, we're going to use a random number generator to find 3 values. So to do that, go online, go to Google search and just say random number generator. And usually the top thing will show up a little on your screen that looks something like this, where I say I want to go from 1 to 71, I want to generate a number. And it'll kick out a number for you. Then you're going to do another one, and then you're going to do another one so that you get 3 numbers. If this repeats, pick a new one. So the general rule is in a random number generator, you always want to have 3, in this case we're selecting 3 unique numbers, 3 different numbers. So click, 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 you're going to get your 3 numbers. And we'd say, well, number 7, if I look at that I look at that spreadsheet of values that we have, the one that had the number 7 is the data point I'm going to pick. So I did this, and I got 3 numbers. I got 7, 6, and 2. And now if you're looking at, and I encourage you to do this, look at the spreadsheet. The random number generator that I had for 7, for the list I had, now I believe I still had my list sorted by male and female, so it might not be the same number that you get. But the one that I had for the 7th one down, for the number of cell phone contacts, was 110. Then I looked at the 6th one down. That was the second number I selected from a random number generator. And the 6th one in my list was 100. And the second one was a 72. Then what I'm going to do is I'm going to take the average of those 3 numbers, and that's 94.33. Right? Then I did this for 5 digits. So I used my random number generator, and I got 5 numbers. It gave me 4, 34, 32, 30, and 9. The 4 row with the random number 4 corresponded to 86, 34 to 100. The 32 had 87 cell phone contacts. The 31 in list had 81. The 9th one had, I'm missing a number because 141 is a lot higher than 9. So either I wrote that number wrong or I wrote that number wrong. But either way, I did this, found the average, and I got 99. This is a sample average. This is a sample average. And what you are going to do is you're going to do this a bunch of times. So you're going to get 3 numbers. So you're going to want to probably start keeping track in a list, maybe make a new spreadsheet, or at least have a well-organized list on a piece of paper. Select 3 random digits. Write them down, 7, 6, and 2. Then pick another 3 random digits. Now, when you do the next set of random digits, it's okay if they repeat. The only time they don't repeat is in the same set, 7, 6, and 2. If I had 7, 2, and 2, I would redo one of those 2s and make it something else. But if I do another random set of 3, n equals 3 numbers, and if maybe I had 62, 2, and 31. All right. This is totally okay. I have a brand new set of random digits. I would find how many cell phone contacts the 62nd person had, how many the second person had, how many the 31st person had. I'm going to find the average. So again, here's what you're going to be doing. You're going to be making a list. You're going to have your random number generators. Okay. You're going to have cell phone, cell contacts. So you're going to have 3 numbers here. You're going to have 3 numbers here. And then your third column is what's the average of those 3. So you're going to get a number. So I would have had in my first one, I would have been like, oh, this is 7, 6, and 2. And then I had 111, 100, and 72, and then 94.33. 2 decimal places is good enough. The first thing you are going to do as part of your assignment is you're going to do this 20 times. So you're going to have 20 averages. Then you are going to find someone else in class who did their assignment, and you are going to get a copy of their 20. And it's possible that they had the exact, like, it's possible that somewhere in this list, I had another 7, 6, and 2, but maybe not in that order. Maybe it went 2, 6, 7. That's okay. Again, the only thing I don't want is I don't want any repeats in each trial. So you're going to talk to 2 other people and get their list of 20. So now you will have a list of, that's right, 60 values. Do a random sample of 3 people 20 times. Record the average for each sample. Find 2 other people from class and get their list of 20 averages and make yourself a list of 60 averages. You're going to take those 60 averages and you're going to make a histogram in stat.blue of the 60 data points. Download that histogram as a JPEG, and you need to be able to discuss the shape center of that graph. How does it look? What's the shape of it? Where's the center of it? You're going to find some information. Look at the summary of the data that it also gives you on that same page. The minimum, the maximum, the median, the average, the standard deviation. Need to find out what is, you're doing that so you know what the average is. What is the standard deviation of all those data points? Then, so this is one thing, right? That's all based on you getting 60 different sets of 3. Now, if you really want to do all 60 yourself, you can, but this is try to get you to not have to do all the work yourself. Then, 6, go back to the spreadsheet and take all of the original data points for the number of cell phone contacts and plug those numbers into StatBlue. And how does the standard deviation you found compare to what you found in number 5? Actually, in general, how does the graph compare to this graph of all those 60 data points? So the original data points as compared to the 60 different averages you do. How does the standard deviation compare? How does the average compare? All of those things. You're going to come to class on Monday, having completed all of this. We'll pull a few of them up and take a look at them on the board and start talking through what this means for us long term. This is really the beginning stages of most of the field of statistics that we're going to study. So again, we're just into chapter 2 and we're kind of hitting on these root elements for what is going to be called, no, I shouldn't say is going to be called, what is called, what you're creating is what's called a sampling distribution. It's called a sampling distribution because it's a distribution, or it's a set of all the data points, all the averages, right? You got 60 averages. We're going to plot those 60 data points, those 60 averages. And it's going to make some type of a shape in a distribution. And that distribution was based on sampling. It wasn't based on the actual data. It was based on sampling of the data. Because where we're going to eventually go is there's going to be a time when we don't know the actual raw data. So we won't know what it looks like. But right now we do. We're going to take that 71 raw data points, make a histogram. How does this compare to that as well? So this is your assignment. It does not need to be submitted, but you should have your data, your histograms downloaded so we can take a look at them. Yours will look slightly different than everybody else's because no one's going to have all the same exact necessarily set of these unless you're a group of 3 people and you just shared all your data just all between yourselves. Then 3 of you would have the same looking thing. But that's what's going on. That's what you're going to do. Have that ready for class on Monday. See you then.